Download this code from codegive.com, link in the description below. OK, let's dive into VPC consistency checks, VPC-CC, for Cisco CCIE Enterprise Infrastructure, formerly Routing and Switching, exam, specifically focusing on the exam number 57391. This is a critical area within VPC, essential for understanding and troubleshooting VPC deployments. I'll break down the concepts, commands, configurations, and considerations, providing code examples where applicable to a simulated Cisco Nexus environment. VPC consistency checks, VPC-CC, the foundation of VPC stability. At its core, VPC-CC is a mechanism to ensure that vital configuration parameters are synchronized and consistent between the primary and secondary VPC peer switches. If inconsistencies exist, VPC might not function as expected, leading to failures and unexpected behavior. It's a proactive way to identify and address potential issues before they impact the network. Why VPC consistency checks are crucial. Asterisk prevent routing loops. Inconsistent VLAN or SVI configurations can create routing loops, severely impacting network performance. Avoid black holes. Misconfigured forwarding behavior can lead to traffic being dropped or routed incorrectly. Maintain port channel consistency. VPC relies heavily on synchronized port channel configurations. Inconsistencies can break connectivity for connected devices. Guarantee predictable behavior. A consistent configuration allows for predictable and reliable forwarding. Facilitate troubleshooting. When troubleshooting VPC issues, VPC-CC provides a foundation to rule out configuration discrepancies. Key areas checked by VPC consistency checks. VPC-CC checks a wide range of configurations to ensure consistency. Here are some of the most important areas. 1. VPC domain ID. The domain ID must match on both VPC peer devices. This is the most fundamental requirement. 2. Peer link configuration. Parameters like the port channel number used for the peer link, VLAN membership, and trunking mode must be identical. 3. Keep alive VLAN. The VLAN used for the VPC peer keep alive must be present and configured identically on both switches. 4. System MAC address. While technically not directly a VPC-CC check, the system MAC address is a critical factor in determining the primary and secondary VPC devices. You'll want to ensure this is manually configured and is not based on the burned-in MAC address, which can lead to unpredictable primary/secondary elections if both switches are from the same hardware batch. 5. Role priority. Determines which device will take on the primary role. Lower values are preferred for the primary. 6. Delay restore timer. Configures how long a VPC member port waits before being brought up after a VPC peer link failure. This should ideally match between peers. 7. Auto recovery. Determines whether a VPC member port will be automatically restored after a VPC peer link failure. This should ideally match between peers. 8. LACP system priority. If LACP is used for port channels, the system priority must be consistent across the VPC domain. 9. VLAN configuration. All VLANs used within the VPC domain, including SVI configurations, must be identical on both switches. This includes VLAN ID, name, MTU, and other properties. 10. SVI configuration. IP addresses, VRF assignments, secondary IP addresses, HSRP/VRRP configuration, if applicable, and other SVI parameters must be consistent. 11. IGMP snooping. If IGMP snooping is enabled, the global configuration and VLAN specific configurations must match. 12 Spanning Tree Protocol, STP. While VPC eliminates many STP concerns, STP is still present. You will want to ensure STP route bridges and configuration are consistent across the VLAN. This is one area where it doesn't have to be exactly the same, but it should be equivalent. 13 Port Channel Configuration, VPC member ports. All VPC member ports must have identical configurations, including VLAN membership, trunking mode, STP settings, and LACP parameters. This is arguably the most complex and error-prone area. 14 ACLS, Access Control Lists. If ACLS are applied to VPC member ports or SVIs, the ACL definitions and application points must be consistent. 15 QoS, Quality of Service. QoS policies and settings applied to VPC member ports or SVIs must match. 16 VRF, Virtual Routing and Forwarding. If VRFs are used, the VRF definitions and route targets must be identical. 17 Routing Protocol Configuration *. While not technically a VPC-CC item, the routing protocol configuration on both VPC peers must be equivalent to ensure consistent routing behavior. This includes routing protocol type, as number, router ID, neighbor configurations, and filters. Configuration and verification commands. We'll explore the commands used to configure and verify VPC, with a particular focus on checking consistency. I'll provide examples based on Cisco NXOS. Example topology *. Let's assume a simple VPC topology with two Nexus switches, Nexus 1 and Nexus 2, connected by a peer link, port channel 10, and a keep alive link. These devices are running NXOS. 1. Basic VPC configuration, Nexus 1 and Nexus 2. Important notes *. Feature VPC * enables the VPC feature. VPC domain ID * assigns a unique ID to the VPC domain. Must match on both switches. Peer keep alive, * configures the keep alive link for monitoring the peer's status. Pay close attention to source and destination IP addresses, which are reversed on each switch. The VRF assignment is important. Interface port channel 10 *. This is the peer link. The VPC peer link command is essential. Interface port channel 20 and port channel 30 *. These are VPC member ports. The VPC ID command is the key to assigning the port channel to the VPC domain. The VPC ID should be unique per member port channel but must be unique within the VPC domain. Peer gateway * enables the peer gateway feature, allowing each VPC peer to act as the gateway for the VLANs it hosts, even if it isn't the traditional STP route bridge. This improves convergence. IP ARP synchronize and IPv6 ND synchronize * synchronizes ARP and IPv6 neighbor discovery entries across the VPC peers. This is crucial for smooth failover. System MAC address and role priority * these settings affect the primary/secondary election process. 2. Verifying VPC status and consistency ***. The following commands are indispensable for checking the VPC status and identifying inconsistencies. Show VPC *. This is your go-to command. It provides a summary of the VPC configuration, status, and consistency check results. Peer status * should be peer adjacency established. VPC keep alive status * should be peer is alive. Configuration consistency * should be success. If it's failed, the output will usually provide details about the inconsistencies. Per VLAN consistency * should be success. A failure indicates a VLAN configuration issue. Asterisk type 2 consistency asterisk should be success. Type 2 objects are those that are checked on a per VLAN basis, VLANs, SVIs. A failure in type 2 means that inconsistencies are present. Asterisk VPC role asterisk indicates whether the switch is the primary or secondary. Asterisk other parameters asterisk verify the other parameters match your intended configuration. Asterisk show VPC statistics peer keep alive asterisk displays statistics related to the keep alive messages. Use this to diagnose issues with the keep alive link. Asterisk show VPC role asterisk shows the VPC role priority, and system MAC address. Crucially asterisk ensure the system MAC address is consistent between the two switches. Typically, this is a manually configured MAC address used specifically for the VPC domain. Asterisk show VLAN brief asterisk shows the VLANs and their status. Verify that all expected VLANs are present on both switches. Asterisk show interface brief asterisk shows the status of interfaces. Verify that the peer link and VPC member ports are up and in the correct VLANs. Asterisk show running config interface port channel 10, and other relevant interfaces displays the configuration of the peer link and member ports. Carefully compare the configurations on both switches. Asterisk show running config VPC asterisk show VPC specific configurations. Example of an inconsistency and troubleshooting. Let's say you see this on Nexus 1. You need to investigate further. Unfortunately, the output of show VPC alone isn't always enough to pinpoint the exact cause. You need to systematically check the configurations. Scenario asterisk the VLAN name is different on Nexus 2. On Nexus 1, you have VLAN 10, name data VLAN 10. On Nexus 2, you have VLAN 10, name data VLANX. Asterisk step 1, check VLAN configurations. The show VLAN brief output reveals the VLAN name discrepancy. Asterisk step 2, correct the inconsistency. On Nexus 2, change the VLAN name. Asterisk step 3, verify that consistency is restored. Now configuration consistency should be success. More complex examples. Asterisk inconsistent LACP system priority asterisk if you are using LACP on VPC member ports, the LACP system priority must be the same on both VPC peers. If they are different, you will see issues with port channel formation and forwarding. Asterisk check asterisk show lacked system priority on both switches. Asterisk correct asterisk lacked system priority value in global configuration mode on one or both switches to make them match. Asterisk inconsistent VLAN trunk allowed VLANs asterisk if the switch port trunk allowed VLAN configuration is different on VPC member ports, traffic might not be forwarded correctly. Asterisk check asterisk show running config interface port channel number on both switches. Asterisk correct asterisk modify the switch port trunk allowed VLAN configuration on one or both switches to ensure they are identical. Asterisk inconsistent SVI configurations asterisk this is a very common source of problems. Differences in IP addresses, VRF assignments, HSRP/VRRP settings, or ACLS on SVIs can cause routing loops or forwarding failures. Asterisk check asterisk show running config interface VLAN ID on both switches. Asterisk correct asterisk carefully review and align the SVI configurations, ensuring that all parameters are identical. Important considerations for the CCIE exam asterisk. Asterisk understand the underlying principles asterisk don't just memorize commands. Know why consistency is essential for VPC to function correctly. Asterisk troubleshooting methodology asterisk be able to systematically troubleshoot VPC inconsistencies. Start with the high-level show VPC command, then drill down into specific configurations using show running config, show VLAN brief, show interface brief, and other relevant commands. *NXOS knowledge *Be comfortable with NXOS configuration syntax and command line interface. *Practical experience *Hands-on experience configuring and troubleshooting VPC is invaluable. Use a lab environment, physical or virtual, to practice. Type 1 vs Type 2 consistency Understand the differences between configuration items checked with Type 1, global, all switches, and Type 2, per VLAN, consistency mechanisms. Nexus family differences Be aware of any minor differences in VPC configuration or verification commands across different Nexus platform families, example Nexus 9000 versus Nexus 7000. Code examples in Python, using NX API. While you won't be configuring VPC directly through Python on the exam, understanding how to use NX API, Nexus API, to verify configurations is a valuable skill. Here's a basic example. Explanation *. 1 imports *. The script uses the requests library to make HTTP requests to the Nexus switch and JSON to parse the response. 2 credentials *. Replace the placeholder credentials with your actual Nexus switch credentials. Never hard-code credentials in production code. 3 get_VPC_status function *. Constructs the NX API URL. * creates a JSON payload containing the CLI command show VPC. * makes a post request to the NX API endpoint. * parses the JSON response and extracts the VPC peer status and configuration consistency. * returns the extracted information. 4 if __name__ equals __main__ block *. Calls the get_VPC_status function to retrieve the VPC status. * prints the VPC peer status and configuration consistency. * displays a warning message if configuration inconsistencies are detected. Important notes about NX API *. Enable NX API You must enable NX API on the Nexus switch with feature copy. Then, configure HTTP or HTTPS access. Authentication Use strong passwords and consider using certificate-based authentication in production environments. Security NX API exposes the switch's configuration and operational data. Protect access to NX API using strong authentication and authorization. Limit access to authorized users and systems only. JSON parsing The JSON response from NX API can be complex. Use a JSON viewer or a tool like JQ to understand the structure of the response and extract the data you need. Verify equals false This is used to disable SSL certificate verification, which is generally not recommended for production environments. Use only in lab/testing environments. In production, obtain a valid SSL certificate and configure your script to verify it. In conclusion VPC consistency checks are a cornerstone of a stable and reliable VPC deployment. Mastering the configuration, verification commands, and troubleshooting techniques is essential for success in the CCIE Enterprise Infrastructure exam and for real-world network administration. Practice regularly in a lab environment, pay close attention to detail, and develop a systematic approach to identifying and resolving inconsistencies. Good luck! Remember to adapt the information and code examples to your specific lab environment and test scenarios.